All right, today we're going to do two things. We're going to learn about quartiles and percentiles. Now, as stressed here, quartiles are three numbers. So we're talking about individual numbers. And there are three of them. So three individual numbers that group data into four equal parts. Now, hopefully that makes sense to you. Quartile, what do you suppose the root word of quartile is? Quarter, yeah. And 4 quarters in a dollar, a quarter is 1/4. So it breaks them into four equal parts. So what we're going to do today, and our goal eventually is to make a box and whisker plot, but in order to do that, first we have to go through this and find our quartiles. So we're going to find three different numbers. That's going to break these into four equal groups. So here's a set of numbers. Please copy those. Put those into your notes. Here is a set of numbers. Each one of the quartiles is a median. So we're going to find three medians. The median in a set of data is what? What is a median in a set of data? The middle number. So we're going to find three middle numbers. 46. So in order to find the median, what do I have to do with my data set? Put them in numerical order. Now, when we were just doing the median with in the second lesson, I said it didn't matter. You could go smallest to largest or largest to smallest. Now that we're doing a quartile, it does matter. You have to put them in order from least to greatest. So that's always going to be the first step when you're working on quartiles and box and whisker plots. The first thing you have to do is put them in order from least to greatest. So I'm going to do that with these numbers. Smallest number is 18, then 28, then 29, 31, 37, 40, 42, 46, and then 56 and 58. So now that I have them in order from least to greatest, now I can find the quartiles. Now, it may not make sense to you at first because it's not in order. The first quartile you find is the second quartile because the second quartile is the median of all the data. It's the middle point of all the numbers. So if you were just finding the median of a group of numbers, that's what the second quartile is. And what it does is it'll break all the data into two equal groups, all the numbers. All the other numbers, I should say. All right, so I want to find the second quartile, which is the median. How would I find the median of all those numbers? Well, it's the middle number, right? So first I'd figure out how many I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. Is there one middle number? No. The fifth and sixth numbers will be the middle ones, correct? So it is numbers 37 and 40. These two are the middle two numbers. What do I now have to do with those two? Add them, divide by 2. Now I have to find the average of those two, right? 37 plus 40 divided by 2. Do you know a shortcut to find the middle of two numbers, the average of two numbers? It's just the middle point, right? What's halfway in between 37 and 40? 38.5. Because what's the distance between those two? 3. What's half of 3? 1.5. 37 and 1.5 is 38.5. Now, if you can't do that, that's fine. Use your calculator. 37 plus 40 equals, divided by 2. Still get the same thing. Either way, I'm just giving you another way to find it. So the median, the second quartile is right there at 38.5. There's my second quartile. What that does is that now breaks all the numbers, all of them, into two groups. All of those below the second quartile and all of those above the second quartile. And that is done for a reason. I can now find the first quartile and the third quartile. The first quartile is the median of the data below this. So that's why I broke that into this group. Now the first quartile, these first 5 numbers, it's the median of that. What is the median of those numbers? 29. That's right. It's just the one in the middle. Good. Right there. How do I know that? Well, I have 5 numbers, which means number 3 is right in the middle. So 29 is there. That's the median. So now I do the same thing with the second half of numbers. 46. Good. There are 5 numbers here. 40, 42, 46, 56, 58. 46 is the one in the middle. That's the third quartile, yes. Oh, I'm sorry, I didn't reveal that, did I? The median of the data above the second quartile, that's the third one. There is no fourth quartile. There's just first, second, third. Because the quartiles actually break them into four groups of numbers that are equal. Right? In between here, I have 2 numbers here. I have 2 numbers here, 2 numbers here, and 2 numbers here. Those are 4 groups of 2. The quartiles have broken them into that. All right, 2 other things with quartiles. The next thing is called the interquartile range, and it is simply the difference between the first and third quartiles. So what that means is this. Those are both numbers, right? First and third quartiles. That means it's the number for the third quartile minus the number for the first quartile. And it's always the third minus the first, because the third will always be a bigger number since they were put in order from smallest to largest, right? So using the data set we just had, the third quartile was 46. The first quartile was 29. So 46 minus 29 is 17. The interquartile range, that's where the majority of the numbers will fall in a data set. Now, in a few minutes, when we make this box and whisker plot, your natural question will be, when am I going to use this? And I'll be honest with you, you won't. After the semester exam, you'll never do this garbage again, unless you become a statistician. However, you will now have the ability as an adult to look at statistics analytically, or more analytically. A lot of adults are intimidated by numbers, and especially statistics. And that's how they're able to be duped. Yes, sir? You analyze something, you think about it critically. No problem. Anytime. I'm there for you. Okay. A box and whisker plot is a graph that uses quartiles to illustrate the interquartile range. It just shows you on a graph how large it is from the first quartile all the way to the third. That's all it means. It sounds a lot worse than it is. It's not a disease. The interquartile range is not something that is a virus. It sounds like it, but feel free to take care of that Monday for me while you're in lab. I'm sure he's got a pair of pruning shears down there somewhere. I'm sure you do. Feel free to see if Mr. Kemp will let you. I'd appreciate it. I might even throw some bonus points your way. Because you only have to be in here for 40-some minutes. I got to be here all day. All right, we're going to make a box and whisker plot using that data set and that line graph. Now, in order to have a box and whisker plot, you must have a number line. So go ahead and put this in your notes, and then work along with me while I'm making this box and whisker plot. Yes, ma'am. They will be, yes. Okay, you're going to cut right to the chase, no problem. They're your notes. Do as you see fit. Putting up with that annoying noise if I could have just opened up and broken the branch off? Let me answer that for you. No. None of the windows in the building open except for the one in the treasurer's office. Alright. First thing I have to do whenever I'm going to make a box and whisker plot, which means I have to find the quartiles, is I have to do what with the data set? What do I have to do with those numbers? Put them in order. That's right. So 175 is the smallest number. 185, 225, 229, 235, 257, 265, 299, and 300. All right, now they're all in order. First step, find the second quartile. Second quartile is 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's the fifth number. 1, 2, 3, 4, 5. There it is, 235. There's my second quartile. Which means my first and third quartile, what will I have to do? Well, look at my first quartile. How many numbers are there? How many are in the middle then? 2. So if you start off with an even number of numbers, like with this one, I only have to do that average thing once, right? Just for the second quartile. But if you start off with an odd number of numbers, like here, you'll have to do that average thing twice for the first and third. But that's not a huge deal. 185 and 225 are in the middle, so add them together and divide by 2, or they're 40 apart, right? Half of 40 is 20, 185 and 20, 205. So the first quartile is 205. I just averaged them. Yes, sir. Yes, help yourself. Yeah, if you want a calculator, just go ahead and get one. You'll need it today. Now we're going to do the third quartile. So once again, there are 2 in the middle, 265 and 299. Add those together, divide by 2, and you should get 282. That was pretty fast, huh? You impressed? You shouldn't be. It's the 4th time I've taught this lesson today. I just have it memorized. All right, now I have all the information I need. That's it for as far as computation. Now I'm going to make the box and whisker plot. But as far as the math goes, I'm done. The box and whisker plot. What you'll do is you're going to graph these 3 points underneath the number line and create the box out of that. Then the whiskers are the lowest number and the highest number. And you put those points out there and draw lines to them. Here's how you do it. 205, it's going to be about right there. I draw a line there, put the point in the middle, 205. Now, do I know that 205 is exactly right there? No, I'm estimating, right? But what allows me to do that is then I put the line underneath, put the point in, and then label that 205. Now I know that's where 205 is. 235 is going to be about right here. Draw the line, put the point, label it. 282 will be about right here. Draw the line, put the point in, label it. This is now my box. Looks like a box now, doesn't it? Amuse me and say yes. Thank you. Now I just need to put in my smallest number, my smallest point, and my largest point. 175 is approximately right here. Just the point. Draw the line to connect it to the box. 300 is right here. Point. Draw the line. Label it. That is now a box and whisker plot. And what the box and whisker plot can be used to illustrate is how large this range is. The majority of the numbers will fall in the interquartile range. See how the whiskers aren't very far out from the box? That means the majority of the numbers are there are no extreme values, which means what? The second lesson. What was part of that lesson? To figure out when is it appropriate to use the mean, find the average, when is it appropriate to use the median. You can look at a box and whisker plot. If there are no extreme values out here, the whiskers aren't very far out, the interquartile range is a decent size, then it's the mean. If the whiskers are really long, then you have some extreme values. It's most appropriate to use the median to describe the data set. All right. Do not copy all this down. Just put the numbers down with me and make the box and whisker plot. All right, here's a list of the alphabetical list, of the highest waterfalls in the world. Now keep in mind, that's in feet. 1 mile is 5,280 feet. That means 1,600 feet is about a quarter of a mile. And what about this one? This would be over half a mile high, right? 5,280 feet would be 1 mile. This would be over half a mile, straight down. If you go over that in a barrel, that's going to leave a mark. That would feel less than average when you hit. All right. So if I want to make a box and whisker plot of this, what's the first thing I have to do with all the numbers? Put them in order. So 1,600 is the smallest number. Then 1,904. Oh, nope. 1612. 1612, 1904, 2000, 2014, 2149, 2425, and 3212. So how many numbers is that? 1, 2, 3, 4, 5, 6, 7, 8. So when I find my first median, is there one number or two? Two, because there's an even number of numbers. So to find the median, the second quartile, which two numbers do I use? 2000 and 2014. Those are the two middle numbers. So what's the average of those two? You got it. 2007. Look at it. These are 0. That's 14. What's half of 14? 7. That's your middle point. So 2007. That's the second quartile. All right. Now I have my bottom half of numbers. What's the first quartile there? That's the middle number, 1612. What's the middle number down here of these three? 2425. This is what it does. When you find that, it breaks them into even groups. Okay, so we caught our mistake. And we start in the even number of numbers. 2007 is our second quartile, which means we have 4 numbers below it and 4 numbers above it, value-wise on the number line. So the first quartile is going to be the average of those two. So 1612 plus 1904, thank you, 1758. That's the first quartile. All right, if we look at then the second half of numbers, we're going to use 2149 and 2425. I add those two together and divide by 2 to get the average of, oh wow, in stereo, 2287. All right, those are the 3 numbers. I'm done computing now. The box and whisker plot I can make. So I'm going to draw my number line. And this is what you'll do on your homework tonight. There are only 2 restrictions that I give you when you make your number lines. 1, the numbers have to go from smaller to larger, left to right. Right? You have to follow that. Smaller numbers on the left, larger numbers on the right. And when you make your little hash marks with the units, you have to use the same unit mark for each one. They have to be equal, meaning they all have to go up by 100 or 200 or 300 or 20 or 40. Pick something. Now, as I look at this, my smallest number is 1600. My largest number is 3212. So my number line is going to range from 1600 to 3200. Now, I can go up by 200 if I want. I can go up by 500. 1,000 might be a little steep, but you get to pick on your number line. I'm going to go up by 400 on this because both 16 and 32 are divisible by 4. So 1600, 2000, 2400, 2800, and then 3200. Does somebody have a question for me? What about this bottom number? Oh, 86? Okay. You sure? No, it's 2287. You made a mistake, yeah. This is a 9. Yes, that's how you got it. Okay. Thanks, Robert. Yeah, my handwriting's not good. Some would even say it was bad, which it is, but all right, does anybody else have a question about the 3200? Why do I have to go bigger than 3200? What's my largest number? 3212. I don't have to go above 3200. Here's why. Yeah, that's going to be at the whisker, which means I'm just going to have a point there, and I'm going to label it 3212. So since that's so close to 3200, I don't have to go above it. I can if I want to. That's up to you. All right, let's label my points. 1758. 1700 to be about here, 1758 about right there. 1758. 2007 will be about right here. That's 2007. 2287. 2200. That's right, about right there. 2287. All right, there's. Oh. Oops, having a bad math day. 2287 there. All right. 2287. Now, I'm almost done. I just need my two whiskers. Smallest number, 1600. Label it. Largest one, 3212. I already drew that point. Draw the whisker. Now, look at that. See how far out the 3212 is? What this box means is the majority of the numbers will fall in this range. Does that mean I have an extreme value there? Is there one number that's going to be a lot bigger than all the other ones? Yes, and that's the point of creating a box and whisker plot. All right. The other thing we're doing today is percentile. Percentile is a score that is based upon the percent of those who took the test who achieved at or below your score. It's different than the way most teachers grade in their classroom. Like when the test you take in here, your percentage grade is based upon how many right or wrong, how many you got right or wrong based on the content knowledge. Like when we took the mid-chapter quiz yesterday, you had to know stuff about the 4 different kinds of sampling method, stem and leaf plots, frequency tables, all those things. And your scores, which I'll hand them back, they're graded in a couple minutes, were based upon how many you got right or wrong in reference to the content that was being tested. A percentile is how you scored versus how other people who took the test scored. So you're being rated against other people. So this score compares you to other scores. And it's based from the bottom up. That top number is based from the bottom. bottom score. So if you scored in the 95th percentile, that means 95% of the people scored at or below what you did. So what's the largest percentile you can get? 99th. 99th percentile is the highest. Because if you're the top scorer, you're the top scorer. 99% of people either scored below, at, or below, because there'll be other people equivalent. Yes, sir. It's in your book. It's up to you. If I were you, I would just put percentile and then just put this stuff. It's scores less than or equal to yours divided by the total number score times 100. Because this, your division gives you a decimal number, then you multiply by 100 to turn it into percent. So the kind of question that you could see would be something like are we ready? That. Something like that. Ray took a placement test in order to be accepted into a computer course. His score is 48th from the highest out of 760 students who took the test. Find the percentile rank that Ray achieved. I would just write the example down, not all the words. So we know we're going to have a fraction or division problem times 100. What number goes on the bottom? 760, because that's the total number of students who took the test. What number goes on top? Okay, figure out what the percentile is. Now that means he's 48 from the top, so go ahead and figure out what that percentile is. Rachel, something the matter? You sure? Okay. What'd you get? Does that make sense? No. That means we have a mistake somewhere, don't we? This means the 48th, he's 48th from the highest. 6th percentile means he's 6th from the bottom. We made a mistake somewhere. Where do we make our mistake? Well, this is definitely right, and this is definitely right. Yeah, what number? This shouldn't be 40. He's 48th from the highest. Very good. 760 minus 48, correct? Yep. That's right. 760 minus, because he's out of 760, we're taking away the 48 that scored above him. That means he's 712th from the bottom. Remember I said that top score is based upon the bottom, how far you are from the bottom. So now redo that with 712 divided by 760. And you get what? Point, which means you're in the 94th percentile. He was in the 94th percentile. So, yeah. Yeah, if it's 5 or above, you do. If it were 93.3, he'd be in the 93rd percentile. Okay. Wait. Since it's Friday.